what do you like want to do for this group project?
I know, right? 10%.
It's serious.
Very.
Yeah, but one night show, what's up?
Nah, that's not right. Yeah.
So then what?
What about the pay?
No, I don't really understand.
Fine. So come, it's on then.
Well, yeah,
that was good. But gluconeogenesis?
Nah,
sure.
People might do that one.
And glycolysis seems to be.
Yeah.
That's the first thing we do. That's not much. I just thought about something over here now.
Cori Stori.
Yeah.
That sounds good, yeah.
Yeah, because people don't know about that.
Alright,
So Cori?
Yeah, Cori.
Team Cori. Cori Stori and friends.
Team Cori's presentation of the Cori cycle. The Cori cycle is also known as the lactic acid cycle, which was discovered by a husband and wife duo by the name of Carl and Gertie Cori. The Cori cycle is a metabolic pathway in which lactic produced by anaerobic glycolysis in the muscle moves to the liver and is converted to glucose, which then returns to the muscles and is converted back to lactic acid. The subsequent video will further elaborate on the Cori cycle.
We're discussing the Cori cycle today. During muscular activity, the breakdown of glycogen produces energy. This is a process called glycolysis, which produces glucose in the form of glucose 6-phosphate. The Cori cycle occurs in both the muscle and the liver. Transport occurs via the blood. Right? When glucose enters the muscle, it is converted to pyruvate by a process called glycolysis. This process produces 2 ATP when there's sufficient oxygen. Pyruvate is fed into the Krebs cycle so that an ATP is constantly being replenished. When there's not enough oxygen, pyruvate undergoes a process called lactic acid fermentation, which converts pyruvate to lactic acid. My bad. Just have to minor complications. Lactic acid fermentation. Right. This process is catalyzed by the enzyme lactate dehydrogenase, which converts, well, pyruvate to lactic acid, yes, but it uses NADH and regenerates NAD+, which is used in other glycolytic reactions. This fermentation step transfers 2 electrons from NADH to NAD+ to reduce pyruvate to lactic acid. Lactic acid, however, builds up in the muscle cells, but this causes muscle cramps. So it travels through the blood as lactic acid and into the liver, where my colleague will now elaborate. Okay, so in the liver, the lactic acid that is coming in will be converted back to pyruvate which then goes on to form glucose. Now, lactic acid to pyruvate, as you can see, and pyruvate to glucose, this is a reverse of what has been occurring in the muscle. So, this means that NAD plus will then be reduced to NADH, and this is going to oxidize lactate to pyruvate, right? And then the pyruvate now goes on to form glucose, which we know as gluconeogenesis. And in this process now, it is very energy dependent, which means that 6 ATP will be needed to drive this process. So once the glucose is made, it is then transported through the blood back into the muscle. So this glucose now will go on to be in any glycolysis reactions. So to recap, glucose is converted to pyruvate, which is then converted to lactic acid. During this process, NADH is oxidized to NAD+, so it reduces pyruvate to lactic acid. The buildup of lactic acid occurs, and it is then transported through the blood into the liver. Once in the liver, it's a reverse process. So lactic acid is going to be converted back to pyruvate. NADH is going to be reduced to NAD plus, is going to be reduced to NADH. Lactic acid is going to be oxidized back to pyruvate, and then pyruvate goes on to form glucose, a process we know as gluconeogenesis. This process is energy dependent, so ATP is needed. So overall, 2 ATP is made at a cost of 6 ATP. So therefore, a net charge of 4 ATP is obtained. To make things simpler, we'll now show you a skit.
Thirsty? It's pretty real hot, girl.
Nah, I cool, I cool.
You okay? Nothing? Huh?
Hold on, eh? Yeah. Alright.
Please have a girl so far, you know.
What's the problem?
Damn right. I saw you come up this all the time.
I can't take this, you know. I fed up with you.
Nah, the relationship, I feel like I get stifled.
Whatever.
Like a different person, can't even know you anymore.
Jed, how does that mean vex? Everything is a problem. Tell what I'm my next man, yes? Jed, I can't wait to see Livingston. I just can't take Hulk. Can't take him. Livingston!
Baby! How you look so scrumptious today? You get it? So baby, where you've been today? You look so good.
Just been working out.
Oh, what part of the body you work today?
I did some muscle work.
So baby, where you going tonight?
Well, actually it's getting kind of oxalates, asamine oxalo at Cramps. So I just want to leave.
Hey!
What's your name?
It's alright, it's better now.
Hey Mariah, so I'm training for this 5K and I'm experiencing a lot of cramps. I know you're doing biochemistry. Can you tell me what's the problem?
Well, cramping is normally associated with the Cori cycle. When the Cori cycle is affected, a disease called hypolactemia occurs. Hypolactemia is the increase of lactic levels within the blood. This occurs when the lactic acid exceeds the extraction rate and reduces the pH of the blood and also affects the efficiency of your muscles. Well, we know that the Cori cycle is the movement from lactic acid from the muscle to the liver and back. There are two types of hypolactemia, type A and type B. Type B is normally caused with disease, drugs, and metabolic effects, whereas type A, which I feel you are experiencing, usually occurs during exercise. Now, I'm going to explain the difference what happens between marathon runners and sprinters. We know when you're exercising, your heart rate increases and your breathing rate will also increase, so that the uptake of oxygen will also increase. What happens? A protein by the name of myosin comes into play and it converts your chemically stored ATP into movement. Also, creatine phosphate is stored in the muscle and is needed to generate the ATP from ADP. During sprinters, the ATP and the creatine phosphate only lasts for 6 seconds. Therefore, the maximum speed only lasts for 6 seconds within sprinters. This is why you can see them slowing down, coming onto the finish line. But in your case, which is the marathon runners, you'd need a higher yield of energy because your longer runs require a greater yield of energy. This is achieved via complete oxidation of glucose into carbon dioxide. Oxidative phosphorylation is slower than glycolysis. Therefore, athletes need to run at a slower pace. Trained marathon runners therefore have an increased glycogen stored, which allows them to go longer distances where compared to a sprinter.
So let's recap the Cori cycle. It takes place when oxygen supply is insufficient and energy must be released through anaerobic activity. Lactate is produced by anaerobic fermentation and is taken up by the liver. The lactate is then enters the Cori cycle and metabolic processes takes place where it is converted into glucose. The buildup of lactate results in a liver disease that is commonly known as hypolactemia. The importance of the cycle prevents lactic acidosis in the muscle under anaerobic conditions and of course with the production of ATP. Very important to remember, the glycolysis part of the cycle produces 2 ATP molecules at a cost of 6 ATP molecules, with an iteration of each cycle being maintained by a net consumption of 4 ATP molecules.
Okay guys, so that was the end of our Cori cycle presentation. I hope it was entertaining as well as informative. Thanks for watching.
During muscular activity, we need a lot of ATP, glucose in the muscles converted into pyruvate. This process is glycolysis in the fat state. Pyruvate to lactate, NADH, the cofactor, NAD plus is regenerated to be used in glycolysis after buildup of lactate causes cramps muscular. So lactate transported in the blood to the liver. Lactate converted to pyruvate cofactor NAD plus, then pyruvate back to glucose is a must. Glucose transported in the blood back to the muscle. Now come on everybody, let's do the Cori cycle hustle. Hey, do the Cori cycle hustle.